All right, so the first thing is when you're going to do command injection, you do have to know some Linux commands. And I get a lot of students that don't know anything about the command line on Linux. So for them, there's this great thing I learned from Ervin Lemus, Linux Journey. And I just added it to my scoring engine so I can see if people are doing it. But this is a wonderful free page with no login or anything, where you just get to learn the basics of Linux. So in the getting started section, there's just a little page of text here explaining the history of Linux, and then one question. And you can put questions here to answers here to see if they're right, or you can put them into my scoring engine to get on there. It doesn't really matter, but there's a whole series of lessons, the basics of Linux, different distributions, then the basic commands and so on. This is a very good place for beginners to go to learn just the fundamental commands on Linux, what's going on, how to manage user, how to manage software, and so on a Linux platform. And once you know a few Linux commands, then you can start exploiting it in command injection. So here's the simplest and perhaps the most famous example of command injection. You'll find this in the configuration page of your router in many cases. There's a place where you can test the internet connection. You can put in an IP address, like you'd use a remote one normally, but on my server, you have to use a local one. So you put in an IP address and you send pings. And then it shows you the result of pings, get a few replies. If you recognize this format, this is the Linux ping response. So that gives you a clue that what happened here is the author of this page, which is me, has done something sloppy and dangerous. Instead of figuring out how to execute a ping from inside PHP, which is the language I wrote this script in that you're sending it to, they just created a line of command line text and then executed with the system command. So I created a command line by taking ping -C2, and then I add the IP address that came from the user, and then I execute it in system. This is the classic way you create a command injection vulnerability. You create a line of code, including something that the user controls, and then execute it as a command. And that means I can just put a semicolon here, ls, and that will be interpreted as ping -C2, this address, semicolon, ls. It'll execute one command, and then it'll execute the second command, and you see a list of the files on the server there. So you can execute any Linux command you want by just adding a semicolon here up to whatever the maximum length is, and that's enough to find various flags. Some of them are easy, some of them are hard to find, and here's some sample commands to try. So there are some files on the server named flag, and there's flags inside those files. You have to figure out ways to print the contents of those files. That's the simplest case of command injection. Now here's one of the ones. You people may be old enough like me to remember a time in the dim and distant past, like 20 years ago and even 10 years ago, when people used to say, Linux is more secure than Windows. Windows is all full of vulnerabilities. And there's a time when Microsoft Office and Internet Explorer and Windows were all full of vulnerabilities, but there were a few really humiliating Linux security failures that caused people to shut up about that. One was the SSL Heartbleed attack, which affected Linux servers, but not Windows. And here's another one, was the ImageMagick vulnerability. About 8 years ago or 6 years ago, this affected most Linux servers. Any server that handled images would have this problem. So let me put an image someplace. There's an image. I'm going to save this image on my desktop. There's WC logo, I think .ping. I don't know what the extension is, doesn't really matter. All right. Just a moment. There it is. I did a WC logo.ping. Good. All right. Now, what this page does is it processes images. It's something you'd find on Facebook or Twitter or any kind of forum that uses images. You can upload an image, and then it will turn it into a certain size and format by converting it using the ImageMagick library, which is a very common standard library to do this. And what I added to this forum code I just copied from some open source project is it prints out the commands it's executing. So here's the command that executes the uploaded file into a 300 by 300 thumbnail. That's what, and this is a convert command as part of the ImageMagick library. So it made a thumbnail, and when you click the thumbnail, you see the original image. You'll see this on your profile on almost any social network. So that's this thing working as intended. And here's the vulnerability. You make a text file containing this content, and let me bring that over. All right, here's a text editor. I put in that content. There we go. And then I save it with a file extension that makes it look like an image. So I'll save that. On my desktop is fine as exploit.jpg. Doesn't really matter what extension. So it will be interpreted as a JPEG image. Now, what's going on is the developers of the ImageMagick library, for some reason, decided to add extra features to their product. So not only can it process images, but you can add a background color to an image, or you can fill a region. So here it's going to fill a region of this size with a color, and you can fill the color not just with a static color, but with a color fetched from a web server. So they have a URL here, and now what happens is it did this by executing the curl command, just the way I executed the ping command in the previous one, and it took this URL that came from the user. So the punctuation marks are a little different, but the end result is the same. You can put in a URL, and then if you add a couple of punctuation marks, you can now put an executable command here, and it will execute it. So this is going to echo the string hello, and then it's going to execute the date command after it's done supposedly processing this image. So I upload that file, exploit, and upload it. And now it runs the convert command, and here it is printing hello and the date. So now I can execute arbitrary commands on the server by modifying this fake image file. For example, if I change that date to, I'll just change that echo hello to ls. Then I'll get a list of files in whatever the current directory is. I might want to know what the directory is. That's print working directory. So if I upload this image again and process it, it will now do that. So here's a list of files on the server. There's the date, and somewhere was who am I? I'm not seeing it, but anyway. So as you see, you can now execute codes on the server. And again, there are some flags defined on the server by executing files there. And the third one is more of the same. Drupal is a content management system, a rival to WordPress. It's not at all as popular as WordPress, but a lot of sites use it. And it's had a whole series of really severe vulnerabilities called Drupalgeddon and Drupalgeddon 2 and Drupalgeddon 3. And this is one of them. So I have a vulnerable Drupal server here, which appears to be up. Good. And I put an authentication on it to stop people from trashing it so much. And I'll probably restore it from backup before you start, because it tends to get trashed by students. But anyways, username is student1 and password is student1. And then you see this website that has no content, but it is a running web server with Drupal on it, and it's running a really old, vulnerable version of Drupal. And the point of this one is you need a machine that can run Python, which you have, and then you run this Python script. And there is a place somewhere in the Drupal site, something to do with registering users, where you can put in some data, and one of the fields when you register a user has a command injection vulnerability. And you will see it here. There. Here's where you can inject commands. Echo, a smiley face, pipe T, your name.txt. That's the command that was executed. One of those fields had a similar command injection vulnerability. So in here, you cannot insert a greater than sign. And you'll find this frequently when exploiting vulnerabilities of all kinds, that certain characters are blocked by the processing. So since they can't use a greater than sign to redirect the output of this command into a file, they used pipe T, which accomplishes the same thing, but it doesn't involve using a forbidden character. And so when you run this script, it will create a file on the server with this name, which you can then see. One thing about this one is you can write a new file, but you cannot modify an existing file. So every single time you perform the attack, you have to change this name to a different name. And the server gradually gets a whole lot of files in there. So I'll restore this server while you folks are working, so it's fresh and working. And again, there are some flags defined on that server. So you have to figure out how to run ls and find commands to find it, and then some kind of command to print out the contents of those files. So that's an introduction to command injection, and you should try doing that.